Welcome to Tercen's presentation for the Cyto 2022 Technology Showcase. When we look at the challenges facing the cytometry community, we see a vista where algorithms are underutilized. There is a lack of knowledge of coding and best practice for data analysis. Analysis pipelines are difficult to collaborate on, and data administration tasks drag on the efficiency of research teams. What if every algorithm was an app? Better still, what if the whole analysis pipeline was an app? What if these apps weren't locked down and biologists could interact with their data on the fly without knowing any code? What if they could present their findings to the team by simply emailing a link? Tercen excels because it presents a platform for the entire research team to use. A platform that streamlines their interactions with each other and helps solve their problems. Tercen's analysis pipelines are customizable to an experimental design and modifiable as the research progresses. Algorithms can be used from public or private sources, and they're used in their original programming language. Bioinformaticians can deploy algorithms to large teams, and biologists can tweak visualizations without needing to know how to code. The data, findings, visualizations, explanatory notes, and audit logs are all individually shareable or shareable together as a project. And when they're shared, collaborators can add and modify the research. The IT team also gains the benefit of containerized deployment. Tercen comes with a very large library of algorithms, and we are constantly adding to it. It is a simple process for a bioinformatician to wrap their own code or shiny application and load to Tercen from an open source or a private repository. Here we see a pipeline running analysis on a 9-color T-cells stimulation dataset. This pipeline shows a 40-color PBMC experiment using a spectral flow cytometer. This one analyzes immune response to the West Nile virus and utilizes the TrackSum algorithm. That's 17 algorithms across 3 pipelines, all running concurrently on the same system. Here, I'm building a visualization of clusters calculated by the Tisney algorithm. I'm splitting them by donor ID, which I got from clinical annotations. See how Tercen draws the graph on the fly and recalculates it as I interact with it. Now I'll take a different approach to the same data. This time I'll divide the clusters by channel markers and use measurements that were scaled by the ACE and H algorithm so they can be compared. There's no returning to the bioinformatician for even significant adjustments to plots like this. Tercen projects come with built-in notebooks. They show live visualizations that you can interact with. The data, the analysis pipelines, and the audit logs can all be clicked on during a presentation or emailed in a link to share them instantly. The person you share with can collaborate on the project. We have a great team at Tercen of bioinformaticians and scientists, and exciting collaborations in the flow cytometry industry. Everything we do comes from experience of the challenges faced by researchers as they try to use big data. Tercen is a young company, but our founders Faris and Alex have been dreaming of this for decades, and our advisor Mike keeps us focused on delivering for the single-cell omics community. Tercen's technology is built in 3 layers. A statistical layer which deploys and runs code from any source, a relational layer which controls the link between data and the calculations made on it, and a visualization layer where the user interacts. The data modeling structure is innovative at Tercen, and we have patents pending. We hope you enjoyed our short presentation on Tercen and found it informative. If you'd like to learn more, we would be very happy to chat with you. Drop by booth number 245 and say hello. Or reach out to us on email or LinkedIn and we can organise to meet sometime. Thanks for watching.